So the inequality absolute value of x over x minus 3 is less than or equal to 2. What I'm going to do is, absolute means it can either be positive or negative. So I'll say positive or negative x divided by x minus 3 is less than or equal to 0. So when I bring in this, the absolute is no longer there. And so I'll get this positive and multiply with this term that is going to give us x divided by x minus 3 less than or equal to 2. And then you have got this negative. So instead of me distributing this negative to everything here, I'm going to divide both sides by a negative. This side by a negative, also this side by a negative. So it becomes x divided by x minus 3. Whenever we divide by a negative, when the negative was attached to the x, the sign changes, and so it becomes greater than or equal to negative 2. Remember, it is positive 2, but I've divided both sides by negative, so that's why a negative 2, and the sign also has what? Changed. So from this point, I'll make sure that there's a 0 at one end. So for rational inequalities, never cross multiply. Don't say over 1 and then you multiply this by this. So that would be a very big mistake. So this is x divided by x minus 3, and then we take the to the other side, less than or equal to 0. And then also here x divided by x minus 3, will take this negative 2, it becomes positive 2, greater than or equal to 0. So this is now the same as over 1. This is also the same as over 1. So here we'll multiply this by this to measure the single fraction. That will be x, and then negative 2 times x and also times negative 3. That is going to be negative 2x and then a positive 6. And that will be divided by x minus 3, and that will be less than or equal to 0. Also the other side, that will be x plus 2x minus 6 divided by x minus 3. What I've done is this times this, that has given us the x, and then x times 2, that is the 2x, and negative 3 times 2, that is a negative 6, we can see. So this will be greater than or equal to 0. So from here, we can simplify what's on top. That will give us negative x plus 6 divided by x minus 3 being less than or equal to 0. And then here we're going to have 3x minus 6 divided by x minus 3 being greater than or equal to 0. Now that we've reached at this point, I'm going to get both sides, and uh, I'm going to equate what's on top to 0 and also what's down to 0. Starting with this one side, if I get what's on top, I equate to 0. Negative x plus 6 is equal to 0. I'm going to find that I'll take x this side, it will become positive. So 6 is going to be equal to x, or x is equal to 6. And then I equate what's down to 0, that will be x minus 3 is equal to 0. That will give us x being equal to a positive 3. And then also this one, I equate what's on top to 0. 3x minus 6 is equal to 0. I'll take 6 to the other side and then divide by 3. X is going to give us 2. And then also x minus 3 is equal to 0. Taking 3 the other side, x is going to be equal to positive 3. Now that I'm here, I'm going to put these values on a number line. So for here we've got 3 and 6. Which one is smaller? Well, 3 is small, so it will be on the left of the number line, and then 6 there. So we had these two factors which we equated to 0, and those are the ones I'm going to write, x minus 3, and also I can as well write that as 6 minus x. And I'll do the same also the other side. Okay, so again here we have got x is equal to 3 and x is equal to 2. 3 is bigger, so it's going to be on the right, and 2 is smaller, it will be on the left of the number line. And I'm going to put these factors, 3x minus 6 and also x minus 3. So x minus 3 there, and then 3x minus 6. Now what happens When we equated this to 0, we found 3. So what happens when we use numbers above a 3, like a 4? We put a 4 here, it will be positive. So as long as we use numbers above 3, the sign is going to be positive. And then anything below 3 will be negative. Can think of a 2, we put a 2 here, that will be negative. When we equated this to 0, we found x as 6. What happens when you use numbers above 6? Can think of a 7, we put here. 6 minus 7, that will be negative. And anything that we use, as long as it is smaller than 6, will be always positive. I've put on the in the wrong column, so it will always be positive. We can think of a 5. A 5 is below 6, we put here to be positive. Now because these two factors are dividing, I'm going to find their quotient. Positive divided by negative, that's negative. Positive over positive, positive. Negative over positive, negative. I'm going to do the same over the other side. When we equate this to 0, found a 3. Anything above 3 will be positive, and anything below 3 will be negative. When we equate this to 0, we found what? A 2. Anything above 2 is going to give us positive. We can think of a 3. We put a 3 here. 3 times 3 is a 9. 9 minus 6 is positive. And anything below a 3 is going to be a 2 is going to be negative. We can think of a 1. We put a 1 here to be negative. And so also these two terms were dividing. We find the quotient. Negative over negative, positive. Positive over negative, negative. Positive over positive is positive. Now for this one, we are interested where the values of x are less than or equal to 0. What does it mean, less than or equal to? We are interested in the point where the values are what? Are negative. Okay, that is the meaning of less than or equal to 0. It's only negative numbers which are less than or equal to 0. So we are starting from this point going, so I'm getting where the quotient is negative, going in that direction, and also here going in this direction. Now notice that this is less than or equal to, so we should also include the 3 and the 6. But one thing, in the denominator should never be equal to 0. So even if this rational function is saying less than or equal to, we should never include a 3, because the 3 will give us a 0 in the denominator, but we can include what? We can include a 6 there. Now here we are interested where x, the values of x are greater than or equal to 0, where it will give us greater than or equal to 0, and that is where the quotient is positive. So it is starting from here going in this direction, and also starting here going in this direction. Again, it is greater than or equal to, so we should include the terms, but we shouldn't include the one that will give us 0 in the denominator, that is a 3. So we can include this one. So when we have done this, now we need to combine our two solution sets to make one, because this is just one question that we have. So I'm now going to write one number line. I'm going to get a 2, and then a 3, and then a 6. I've just gotten these same values which are here. So those are the ones I'll put there. Now for the first one here, it is 3 to infinity. So I'm now going to put those values. 3 is here to infinity. And also 2 to negative infinity, and we're including 2, so it's there, going in that direction. And then the other one, it is 6 to infinity. So it starts at this point. We're also including 6. And that goes in that direction. And also 3 to negative infinity, we're not including 3. So here, in this direction. Now, when we do this, when you've combined the solution sets, the question is, are we going to take where the two solution sets, the one in red and the one in white, are intersecting, or we are going to get their union? So what we are going to do is, we can get this region where they are intersecting, we can get this region where it's not intersecting, this region where it's not intersecting, and also this region where they're intersecting. We see whether it's going to work for the original question that we had. So let's get values which are less than a 2. The simplest we can think of is a 0. Let's get a 0. We put in the original expression, we put a 0 on top there. So as long as we have got a 0 on top, over anything, it will always be a 0. So this will be a 0. This will be a 0. So it will be 0 over negative 3, which is a 0. Is 0 less than or equal to 2? Is 0 less than 2? Yes, it is. So this region has worked. So I'm going to tick this region because it has worked. What of between 2 and 3? We can think of a number between 2 and 3 like a 2.5. We get a 2.5 we put here. That will be 2.5 divided by, we get a 2.5 we put here. Now that is 2.5, that is a 2.5 minus 3. That will give us a negative 0.5. But remember that's absolute, so it should be absolute. What is 2.5 divided by 0.5? That is a negative 5. We have got absolute from negative 5. The absolute of negative 5 is a positive 5. Now, is a positive 5 less than or equal to 2? This is not less than 2. That is not true. So this region has refused. What if we get between a 3 and a 6? We can think of a 4. Let's put a 4 there and a 4 there. So 4 minus 1 in the denominator, that will be a 1. And then we've got a 4 on top. That will be 4 over 1. That is a 4. Is 4 less than or equal to 2? Really not. 4 is not less than 2. So this region is also not true. Let's think of a number above 6 like a 7. We get to put in this function. We put a 7 there, we put a 7 there. 7 minus 3, that will be a 4. So that is 7 divided by 4. How many times can 4 go into 7? That is 1 time, remainder 3 over 4. Is 1 less than or equal to 2? Yes, 1 is less than or equal to 2. So it is less than 2. The equal to means we can also include some terms. So this region has worked. So therefore, the final answer, the solution set for this one is going to be where we've ticked. That is from negative infinity to positive 2. Are we including positive 2? Yes, it will be included because it is not undefined. And then also from 6 to what? To infinity. We'll never include infinity, that's why we always use open interval brackets. Are we including 6? Yes, it is included. So this is the solution set for this question. And thank you so much for watching.